We have 3 20-minute talks for you tonight and so much to tell you. Our first speaker is Rick Boone. Rick has been an SRE at Uber for just over 1 year. Before Uber, Rick spent 3 years at Facebook as a production engineer, which is what Facebook calls SRE. And prior to that, Rick worked at a couple of startups in LA, including Buzz Media. Rick is here to give an intro to how SRE became what it is today. So let's welcome Rick to the stage.
So as Chris mentioned, I'm going to talk to you guys a bit about SRE at Uber and how we got to where we are today. So the first question is, who are we? So we are basically a group of engineers from around the company. We all started up in different groups. We have different backgrounds. Some people are operations people, some people are developers. Most of us have a mix of both. We've come from different companies, and we tend to focus on different things, but we all sort of come together with the core mission of moving Uber to be highly performant and highly available. And that includes all of our services, close to 1,000 services that we have. So both from an end user perspective and both internally, we want extremely high availability and high performance. Now that sort of sounds sort of vague and sort of like, well, how do you keep track of what you're doing? And like, how are you moving towards this with almost 1,000 services? So we have about 4 high-level metrics that we'd like to focus on. And so the first is 99.99% uptime, so 4 nines, which actually works out to 4.38 minutes per month that we allow ourselves to be down. A minimal operational cost per trip. Every penny, every unit of cost that we're spending to make a trip happen, internal costs, that's less money that we have for innovation, for creating better products, newer products, creating a better way to have transportation available to the entire world, as available as running water. So we try to minimize the cost as much as we possibly can. A sub-second end user latency. We want this experience to continue being magical. I know that like every time I use Uber, I pull my phone out and I'm like, I have a car here available within 1 or 2 minutes. Well, part of that magic, part of the things that like excites us all to be here is the fact that that magic exists, and that magic will go away every second that a user cannot get a response from us. Every time there's a delay, every time they can't get a car available to them, that magic drops and drops and drops. And high developer velocity. We want developers to have the ability to just basically go out and build amazing products as fast as possible. Our velocity sort of defines everything that we've done here for as long as we've been around. We've moved extremely quickly. I came from a company in which moving fast was basically the core mantra, and I came here and I was surprised beyond belief at how fast this company has even changed that idea of moving fast and basically redefined it for me and for, in my opinion, technology companies. So this is what we use as our sort of core metrics on making sure that SRE is doing the right thing and focusing on the right thing. So focusing on these things, we actually are a pretty small team compared to the size of the company that we are supporting and the amount of services that we're supporting. So you can see here, for every single SRE engineer that we actually have 14 services at the company. We have 30 engineers for each engineer, for every SRE engineer, and we actually have 640 servers for every SRE engineer we have. Now, while those numbers are pretty staggering and pretty insane, what's even crazy is that if I gave this the same talk next week, these numbers would totally change. Not by like a massive amount, but they would change enough to be significant. This amount of services that we have, this is the amount of services that we spin up every single week. We create 10 to 15 services per week. We have to have a engineering platform that supports that and that allows developers not only to be able to create services as they see fit, but also do it rapidly and do it amazingly. And so I like to see ourselves as sort of a level with a well-placed fulcrum, where we are a small team, but we actually have an amazing amount of impact because of how we apply our knowledge and our abilities to the company that we're supporting. So we have 2 types of teams here. We have a first team, which is known as an embedded team, and we have a second team, which is known as an infrastructure lowers team or a horizontal team. And so the first team of embedded engineers, what happens is these engineers are actually, they work with software development teams that work on large platforms. So for instance, like all of our real-time systems, it's systems that actually provide the immediacy of a trip or a team that works on a business logic backend, for instance, handling all the users of Uber, et cetera. These teams and these systems would be so large and so unique that actually need specialized infrastructure and specialized SRE assistance. So you're not going to find them just saying, oh, I can just do whatever. They actually need like someone in-house 24/7, well, 8 hours a day, 10 hours a day, whatever, but always being available to actually help them with their unique problems. These teams tend to be co-owners of whatever they're working on. So you will find that this is a shared on-call, this is a shared ownership of whatever systems they're working on. And the other teams, these horizontal infrastructure at large teams, these teams work on large swaths of the company. So for instance, security, storage, cloud, compute, observability. And these teams are sort of sole owners of this. So for instance, a database team might own, a database SRE team might own availability and performance of all databases at Uber. And one thing that I find really interesting is that observability here, we actually have moved observability directly within SRE. So we are no longer sort of just like reaching across an aisle, sort of saying like, oh, like tell us how you're going to do monitoring, how you're going to do anomaly detection, and we'll sort of apply that to what we're doing. We actually are working hand in hand to get this done, because monitoring is probably the only way, or one of the most important things that we're going to do to get 99.9% uptime, to knowing how much we're spending, to knowing how we can become more efficient in what we're doing. So what is it that we do? So before you can really answer that, you sort of have to know, like, what is Uber? Most people think, oh, I just need a car to go to the doctor's office. I need to get something delivered. Let's pull a phone out. That's it. It does do that, but it's actually 1,000 services, almost. And to me, one of the most important things that we do, and one of like the most interesting engineering challenges that we do, is persistent trip tracking. If you look at most global technology companies, they tend to have point-in-time requests. You go to Google, I need to do a search for cats in pajamas. That's it. That's the request. I get a response back. That's it. I go to Facebook, show me my news feed, show me this picture, show me this comment. That's it. That's a single request. We actually, at any one moment, are holding state for thousands and thousands and thousands of trips around the world at all times. And so to me, that's always been a really interesting engineering challenge. And it sort of like gives you an idea of like, this not only is just why we're different, but like this is the core of what we do. Like holding state of trips, this is the entire thing. You can't get in a car and have your trip just disappear. And then I'm going to list a whole bunch of other things here, which you can read through, but I like to sort of focus on this because these are all the things that make up Uber. And this is things that we are either currently, you know, best in class or becoming best in class. And one of the things I like to sort of focus on is that this happens in 375 cities in 68 countries around the world. So you can sort of imagine how that becomes complex with things like mapping, payment processing, telecommunications. We're not just dealing with like Braintree and Verizon here. We're dealing with everything in every city that we operate in. We're dealing with every payment processor in every city that we operate in. We have to pay out in that currency. So these are sort of the challenges that SRE has to sort of also face, because we have to make sure that these systems are always available and that they're always sort of working well for everything around the world. So with that entire sort of massive environment, what are some of the things that we've done to sort of allow this to happen? What are some of the projects we worked on, some of the wins that we've had? So I'm only going to call out a couple of these, but the overarching thing that I want to really focus on is the fact that, as you can see, I said here, started from the bottom. All of these and almost everything else that we do, either SRE or non-SRE at Uber, tends to be very bottom up. It tends to be very engineer driven. This data center turn up, where we brought up 2 data centers within 7 months in China, no less, was basically this was going to happen. It was decided this is what's going to happen. And the work was left to engineers working on independent services, independent platforms to figure out how you're going to get your service into China. It wasn't like, this is how we're going to move all 1,000 services. It was, you were going to decide what the best thing is for your service. We have a very autonomous world here. We have a very like quick pace world here. And to match that velocity, there's no way we can have a top down sort of like dictatorial engineering environment here. So you'll see almost all of these tend to be engineer driven, either engineer initiated or engineer driven, which is something that I've always found really awesome about working here. So one thing that we also, in my opinion, tend to be very unique on is impact and exposure. So when I say impact, I mean internal impact being an individual's ability to have impact upon the company that they're working in, the organization they're working in. External impact, a single engineer's ability to impact 1 million people, 2 billion people, etc. And high exposure to and influence on internal decisions, which is basically like your ability to not only know what's going on and know what's happening at higher parts of the company, but also have influence on those engineering decisions. Someone's going to build a new service, someone's going to change how a config is generated, etc. Like, change any type of client. You have, what is your ability to actually like be aware of those decisions and influence them? So small startups tend to work here. You have high internal impact because you're a small SRE team, or you might not even be defined as SRE yet, but you're a small infrastructure, DevOps, production engineer, whatever you call it, you're a small team. And you have pretty high impact because if it's just 2 of you, or 3 of you, or 5 of you, you are whatever that percentage is. So if it's 2 of you, you're 50% of all the impact happening at the company. And you have high exposure to and influence on your decisions because basically it's just you making them, or it's you and 2 or 3 other people. Large tech companies tend to be sort of in this sector. High external impact, billion users, 1.5 billion users, and you might be a team of 1,000. That's an amazing impact that you're having upon the world. And whatever you do, you know that when you go home, you're affecting the lives of 1 billion people. And you have high internal impact. You're working on a really amazing project, etc. But this almost always goes away. Unless you are working as a director or senior VP, etc., or CTO, etc., you're not going to have too much exposure or influence of what exactly is happening way up. You're going to sort of be like, well, this is the service I was giving, this is the tool I was given, I'm just going to have to use it. And it works really well, it's amazing, but I don't really know how this came about. We tend to sit in the middle of all of these. Because of some really unique circumstances, hypergrowth, but we have global presence in over 300 cities and a few other things, we actually are able to provide all of these to everyone. And so when you're working at SRE, one of the things that I always love is the fact that we hit all of these. And this to me is really important. I always love the exposure and influence that we tend to have, even as a new engineer. New engineers come in and within a week, they're looking at code, they're having impact on their teams, and they're having impact on the company at large, which is, to me, has always been just a really amazing thing. So how did we get here? So as sort of already mentioned, we are a hyper-growth company. This is the number of services that we have growing week to week. This is a linear scale. This is literally how fast we grow. And this is just the services. This isn't trips. This isn't number of drivers. This is just the number of services internally. We add, as I mentioned, we add about 10 to 15 services per week. Everything that we do, everything that we are, everything that we talk about in the hallways, either directly or indirectly, is affected by how fast we grow. This is it. So along with that, there's been a number of stumbles, but there's also been a number of very rapid, very amazing, in my opinion, adjustments to those stumbles. I'm not going to go through all of these, but you can look at them. But what I do want to point out are a couple of these. So before October 2014, all sort of SRE typical responsibilities were basically on the heads and shoulders of an extremely overtaxed core infra team that was about 10 to 15 people. And we were already at about, I think, 400 to 500 services. And all the requirements, all the needs and requests and engineering requirements of those teams, those services were placed on about 10 to 15 infra people that had to support both very specific requirements, also the entire company at large. By Halloween 2014, this clearly was not going to work, and it wasn't going to work from a human scale and also from just an engineering scale. We basically melted down. I'm not sure if anyone knows, but Halloween and New Year's Eve tend to be our largest days. This is what happened. We basically had overwhelming trip volume, and things internally melted down. We were still able to serve trips, thankfully, but it was a massive wake-up call to the company and to the culture that we needed to shift towards reliability, availability, and performance as a very important thing. These were now going to be first-class citizens. We can no longer just build services, and just hoped that they worked. Between that moment and New Year's Eve 2014, I actually started here, and it was the most intense time of my professional life I've ever had. I was one of these 5. It was an amazing time. It was an intense time. By New Year's Eve, we had 0 problems. We were watching the movie Hackers outside. People were eating pizza. Our CEO was walking around eating pizza. It was an amazing time. And it sort of proved out that, like, if we shift to focusing on reliability, we actually can do this. And even with our small team, we can do this. This is possible. But we have to make this shift. March 2015, a couple of big things happened. We turned up our first non-US data center. When I was in a meeting and heard this was going to happen, I literally thought it was a joke. I started laughing until I realized it wasn't a joke. We also had we had a major database outage, which once again woke us up. While we did great here, we still have a lot more work to do. And we still have to sort of focus on reliability and availability and automation as important aspects of our work. Our first data center came online within 4 months, which I know many of us here that work here are very, very proud of. And by November, we actually established S3 as an official part of Uber. We pulled in many different teams from around the company with this sole purpose of making sure that Uber is always available for everyone around the world. So, like I mentioned, we have unique challenges here, which has sort of defined who we are, and here's the primary ones. So, as I've reiterated and iterated again, we move very fast. It's shocking and surprising how fast we move. When I started, I learned more in probably 4 to 5 weeks than I had in maybe a year of my prior life. I've never worked this fast, and it hasn't really stopped. But it's been amazing, but it's also a very intense world in which to operate. It's especially intense when you are an SRE engineer where your entire almost reason for professional existence is stability and reliability. So what we have to do, we can't stop the company. We can't just say, well, you know what, we know that this is who we are, and we've been this way since day one, but we're going to stop you guys, and we're going to make things really slow and really deliberate and really stable just by dint of us being, a sort of a blocker. We can't do that. So what we've had to do is adapt to this world in which we operate. So most of the SRE engineers here, like I said, we're a small team, but we move at the pace of the company. We also, with that velocity, the company has a number of different information floats around very quickly. Changes happen almost instantaneously. You have to sort of go out and find out what is happening in the world. There is no sort of resting on your laurels and just I'm going to work in this part of the company. That's it. I'm going to put my head down. There is always a sense of I have to understand the full complexity of what's happening here, because it moves too fast for me to sort of assume that what happened yesterday will be the same tomorrow. Along with that, we also have rapid engineer onboarding with, as I already mentioned, sort of like high autonomy. Engineer joins, within days they are writing code, they are looking at diffs, they are with the team, they are making suggestions for things that we should change. There is no, well, you have to talk to these 3 or 4 different people. If you like it, go build it. I often tell people that when I have a new engineer I'm working with, if you want to do it, go build it. We will love it, and you will send it to us, and either it will work or it won't. But we want you to be able to sort of build out whatever you think we need here to be more stable, more performant, more available. This is all sort of a gift and a curse. We have extremely rapid creation. We have a massive amount of achievements. We do it faster than anyone ever thought we could, but we incur technical debt quite often, to be, conservative. What we're working on now is, how do we do this? How do we balance technical quality and speed? Because we can't stop moving this fast, but we cannot sustain the amount of debt that we are incurring. One of these things will break. So how can we actually do this? And I'm actually excited with this because what we tend to do here, in my opinion, is solve problems that no one else really has. And I think it is possible to do this. We have to find the right way to do it. We have a number of autonomous independent platforms. There is no one Uber platform. There is no one way Uber way of doing things. We have 5 to 6 major platforms at the company. They each look at the world in totally separate ways. We have a mapping platform that has a totally different way of looking at the world than our real-time sort of front-end marketplace does. They have different challenges, they have different needs, they have different solutions, they have a different engineering culture. That's awesome, because they're able to move at their own pace and solve their problems as they see fit. But the problem is that SRE, which sort of exists in this layer above all this, we have to make sure that the mapping system is still as resilient and performant as the real-time system, as the front-end system, because these two things are tightly coupled. We can't have one go down and the other is available, and they're just like, well, they move really fast, so we don't know what to do with them. We have to make sure that those differences are reconciled, and that whatever those differences are, we are able to handle them and make sure that that we're aware of them and that they do not become massive problems at the company. And finally, we have a number of different and really interesting requirements that are either always new or always changing. So efficiency, we have moved extremely quickly, really fast. Well, excuse me, we've gotten really far, really fast. Efficiency might have sort of been sacrificed in some places. Well, that sort of drives up our cost of trip. So we have to fix this. We have product requirements. Trips, as I mentioned, always have to be available, always have to be in state. They cannot just be dropped. We have to have rapid turn-up of services. We start 10 new services a week. There's no way that we can just, well, we don't know what to do with that. We have political and regulatory requirements that are pretty unique to us. We operate, as I said, in so many different countries and cities. And these cities, it's not just like, oh, we just have data in these cities. These are real drivers, real people with real cars. And I'm sure everyone here knows many of the political regulatory issues that we have faced as a company. These are requirements that are translated to actual engineering problems once they get to us. It's not just a product problem, it becomes an engineering problem. And just engineering requirements. We have days in which our traffic will completely jump by multiples. We have to be ready for this. And it's not just 1 or 2 services, it's all 1,000 services, because they're all tightly coupled and they all have to be ready for this. How do we do this? And then the side effects of these requirements. If you look at the political stuff and regulatory things, we move into different countries, there are going to be side effects of these requirements that are pretty challenging. And many people have never really seen this before. How do we figure this out? And how does SRE figure this stuff out for the company while ensuring that we are stable and performant and fast, but also adhering to whatever these requirements are? That's it. That's all I got.